Hi, Discrete Math students. In this video, I'll be introducing some vocab associated with critical paths. You'll be working with these terms the upcoming week. First, what is the critical path method? Well, the critical path method gives you some steps that lets you determine which jobs or activities are critical in their effect on the total project. This is going to help us schedule all the jobs in a project in order to meet the target date. Many types of businesses use the critical path method. For example, it would be used in a construction project, installing a new computer system, or manufacturing a new piece of equipment. To introduce these terms, we're going to be doing a much less complex project. Let's imagine we're doing a family pizza night. There will be multiple of us working together to make a pizza. I listed some of the key tasks that will need to be done in order to get from the start to the finish where we actually get to eat. As you look at this list, you might notice there are some things that need to be done before the others. These are called prerequisites. The definition of a prerequisite is that it is a task that must be done before the others can be started. So, for example, we need to mix the dough before we can rest and toss it. To help plan our project, we will make a die graph. A die graph is basically a vertex edge graph, which you've been making. The tasks will be the vertices. The difference is that we're going to connect them with arrows to show the direction. This is going to indicate which things need to be done first and then which objects or tasks follow them. So there will be a path from start to the end. I have made a die graph for my family pizza night. You'll notice that it's not one straight path. This is because, as I noted, there will be multiple of us that will be working on the project together. That means that while one person is working on the dough to make it mix and rest, another group could be working on the vegetables. Prerequisites occur before the item, and that is connected to the next task with an arrow. So again, mix is a prerequisite to rest and toss my dough. The goal is to finish up or figure out the earliest finish time. The earliest finish time, also called EFT, is the least amount of time that's needed to complete all of the tasks. We can find this by adding the times on the longest path of the die graph. Looking at my die graphs, I have two different paths to the end. I'm going to add up the times to figure out how long each path will take. To mix, rest and toss, assemble, and bake my pizza takes 70 minutes. 10 plus 30 plus 5 plus 25. Now let's look at the other bottom path. The bottom path, to pick vegetables, prep, assemble, set the table, takes just 35 minutes. This means our EFT is 70 minutes. It's the longest path because 70 minutes will give us time to do everything. The critical path is the path that takes the longest time. Again, this is critical because these things will give us enough time to make sure everything is completed. All the items on there are called critical tasks. The path highlighted in yellow is our critical path. Items on there are called critical tasks. If you are in charge of only a particular task, you might want to know the latest start time, or LST. The latest start time is the deadline for when a task needs to be started in order for the full project to be finished in the EFT. We can find this value by calculating by working backwards and subtracting from the EFT. We'll do a couple of these together. I've made a table to help us keep organized. Remember, we decided that our EFT was 70 minutes. Let's find the latest start time to bake our pizza. Well, if it takes us 25 minutes to bake the pizza, I need to start that 25 minutes before 70. So I can take 70 minus 25 to get the latest start time of 45 minutes. This means that I need to put the pizza in the oven to bake 45 minutes after I start. The latest start time for setting my table is 65 minutes. To find the latest start time for assembly, I must work backwards again on the longest path. So since I needed to bake at 45 minutes, my latest start time to assemble would be 40 minutes. My latest start time to prep the vegetables, subtract another 10, 30 minutes. Let's compare this with the earliest start time. There are some jobs that obviously you can't start right away, like baking the pizza. The earliest start time, or EST, is the soonest a task can be started to allow times for the prerequisites. We calculate this by working forward from the start. Jobs that have no prerequisites, like mixing my dough and picking the vegetables, will have an EST of 0. I can start those right away. To find the EST of prepping vegetables, I have to start from 0 and add the tasks before. So since it takes me 15 minutes to pick my vegetables, I can't start to prep them until 15. The earliest start time to let my dough rest and then toss it, well, I have to mix it first. That takes 10 minutes. So my EST is 10. Now to assemble my pizza, I need to do all the tasks before. So it has to mix, rest, and toss. So the earliest start time to assemble is 40. You'll notice in some cases, the LST and EST are the same. In others, it's different. This means that the prepping vegetables has what's called slack time. Any task that is not on the critical path has extra time to be done. This is called slack time. To calculate the slack time, we subtract the latest start time minus the earliest start time. For example, let's look again at prepping vegetables. The latest I can start it is 30 minutes. The earliest is 15. When I subtract that, I get a slack time of 15 minutes. That means I have an extra 15 minutes to decide when to do the project. We will continue to work with this vocabulary in upcoming assignments.